So, welcome back. Myself, Koushik Bera, Assistant Professor of Holder Institute of Technology in the Civil Engineering Department. So, we will start the remaining portion of shear strength lecture. So, till now, we will describe about the CDCU triaxial test. So, today we will going to the remaining part of civil shear strength in our syllabus. So now relation between sigma 1 and sigma 3 relation at failure. Sigma 1 is vertical and sigma 3 is horizontal. So sigma 1 and sigma 3, if we consider as a Morse circle, this is the sigma 1 and this is the sigma 3, and at the failure element, at the failure type in soil element, so we can see that we can find out sigma 1 equals to sigma 3 tan square 45 degree plus 5 by 2 plus 2c 45 degree plus 5 by 2, and sigma 3 become sigma 1 tan square 45 degree minus 5 by 2 minus 2c tan 45 degree minus 5 by 2. Stress point. So stress point is very important. So we have to find out the stress point. Here, this is a soil element where sigma V is vertical, sigma H is horizontal, and this is the tau, and this is the sigma H. Okay, and sigma H is denoted. This is the less, and sigma V is the higher value. So at this middle position, this is the highest stress point. So this stress point we can denote the sigma V plus sigma H by 2, and tau, this is the shear strength, we can find out the tau equals to sigma V minus sigma H by 2. In this equation we can find out the maximum shear strength, and here we can find out the Morse circle center value. So this is the stress point. We can, if we draw in free space, this is a stress point. During loading, stress path is an important thing. So stress path is a convenient way to keep track of the progress in loading with respect to failure envelope. So stress path during the loading, there is Morse circle is different failure point, stress point we can find out. So this is the failure envelope. So stress path is locus of the stress of the point. Basically, the stress point in previous slide I already described the stress point. If we can join the different type of stress point, this path is called stress path. So this is the below of a failure point. So stress path, the convenient way we can track the progress of loading with respect to the failure envelope. So failure envelope during the loading of a shear stress, and here we can see the different at loading increase, also the sigma H, sigma V changes. So due to this, and also the phi, we can say that the phi also changes. So due to this, this is the C value. Finally, where the failure occurred, we can find out the phi at failure and C also at failure. So if we consider each circle stress point, so this is a locus, or you can say this is a stress point. So failure stress point is this one. So we can say this is the C cos phi with respect to the phi, and this is the tan inverse sin phi. This is the stress point during the loading of shear stress. So pore pressure parameter. So pore pressure parameter means a simple way to estimate the pore pressure changes in under loading in terms of total stress changes. So this is developed by the Skempton pore pressure parameter. So A and B. So if we consider here, the sigma 1 is vertical, sigma 3 is horizontal, and how much due to the loading pore pressure increase. Okay, so you can calculate this way. Skempton developed this equation: del sigma equals to B into in bracket del sigma 3 plus A in bracket del sigma 1 minus del sigma 3, where Skempton pore pressure parameters are A and B. So parameter for B parameter and A parameter, there is some condition and there is some clue to how to find out the B. For saturated soil, the B equivalent to 1, and A parameter AF at failure, we can say that for normally consolidated clay, AF value is near about to 1, and for heavily over consolidated clay, AF is negative value. So if you want to find out the A and B parameter due to the provided by Skempton, you can be use this A and B value. So this is the end of this lecture session. So thanking you. All the best for your future.